So now we are going to look at a data center. So in a data center, we have several racks of servers. So the racks in a data center will consist of several blade servers. These racks are interconnected with each other through switches. The switches sit on top of the racks, and that's why these are called top of the rack switches. These switches allow data to be transferred from one rack server to another one. So they are used for internal routing of data in a data center. The switches can also be used to send data out of the data center or to get data from outside into the data center by using the border gateway router. This router connects the data center to the external internet. Data centers also have load balancers that are used in order to distribute the loads across the different servers. As you can see, there is a hierarchy in the topology inside a data center. This hierarchy is used to partition the different parts of a data center so that they can be used very efficiently. If the demand is lower, then certain parts of the data center can be switched off in order to save on energy. So this hierarchical structure or topology is often typical in data centers. Now, in a data center, if a particular blade server fails, for example here, if this particular blade server fails, then the software that is running on that particular blade server can be migrated over from this particular blade server that has failed to another blade server, either within the same rack or to a different rack server. So S1, that is the software or a application that is running on this particular blade server which failed, can be migrated from this particular rack to any other rack. Let's say we migrate it to the other server here, and S1 will be running on the next server. So since the entire data center is virtualized, that is, all these blade servers are virtualized, that is, the hardware, the underlying hardware resource of the blade server appear as a shared pool of resource. The operating system and the services running or the applications running on top can be easily migrated from one hardware, if it fails, to another one. And that is why data centers provide a very resilient service. One of the new trends in cloud computing, especially in the topology of data center, is to move away from this hierarchical topology. As we see over here, there is a hierarchy of switches that are connecting different parts of the network. The new trend is to move away from this hierarchy to a flat topology. What this means is that there is a much higher degree of interconnection between these switches. So with this high level of interconnection, the hierarchy is flattened, and it is easier to move a particular service or an application from one part of the data center to another part of the data center quite easily, without having to go through many hierarchies. So this is a new trend in the way data centers are operating. So now that we have looked at the internal architecture of a data center, let's look at it from the outside. When you think of cloud and data centers, you might be thinking about some sprawling, windowless warehouse kind of facility with restricted access in some remote areas of Phoenix, San Antonio, or Las Vegas. And that may well be quite true for large data centers of big cloud providers. In fact, some of these data fortresses range between 400,000 square feet to 7 million square feet, like the Citadel data center of Nevada, which is almost twice the size of the Mall of America. But data centers are not necessarily gigantic, and they may be hiding in plain sight in some ordinary looking building, like this one. It houses the data center of the University of Minnesota. It is a secure facility that houses and protects the resources that supports all the IT functions of the university. So let's take a peek inside to see how this fancy technology, the cloud, actually looks. But first we need to get the permission to get inside one of these. Once inside, you may find the staff busy monitoring the servers and their connectivity. The inside of a data center typically looks like this: a vast array of parallel corridors, each with racks of servers lined up on either side, all connected with high-speed, top-of-the-rack switches and miles of network cables. These powerful servers with high processing power and large memory units can host everything from your emails to your social networks to your favorite movies and even this very course video. And if you zoom in closer, this is what each server rack looks like. This is a front view of a server rack with 3 servers from top to bottom. If you notice carefully, in the middle there is a keyboard or KVM that is used to connect to all the servers. Once pulled out, it unfolds into a monitor plus keyboard that technicians can use to access and switch between the different servers. At the very bottom is a large universal power supply or UPS battery backup that will keep the servers running long enough to shut down without crashing, even if there was a power outage. Of course, we make sure there is no power outage in the first place. Now here our friend Bob is working on a Dell PowerEdge R710 rack mount server. He's lifting up the 2 quick release latches that allow the server to slide out on rails. This is generally done to service or remove the server or to replace it with a new one. And here Bob is releasing a locking latch to remove a hard drive from the R710 server. If a hard drive fails, it can be removed and replaced while the server is running. When a new hard drive is inserted back in, the server detects that new one was installed and it starts to use it. The lost data is rebuilt from the data on the other drives. But that's not all. To keep your data available at all times, all data will be backed up and stored as backup copies on other mirror servers. And once it's dark and everyone's left for the day, the magic really begins. These servers come alive and chatter with each other throughout the night because a data center never sleeps. So data centers provide a centralized solution for computation and storage of data. But recently there has been an emerging trend of pushing out some of this intelligence from the core to the edge of the network. And that has led to this emergence of a new area called edge computing. In the next video, we are going to learn about it.